Alright, so this is going to be an overview and a demonstration of my Science Symposium project. This is a weather alert system. This was designed by Nick Van Wagner and Tegan Farrell for the 2020 Kingsley High School Science Symposium. I'm going to start out with an overview of the system. First, I'd like to thank Sentry Siren Incorporated for their generous donation of an E4 industrial siren. You'll see that being tested later. Under this Gladware here is a wind sensor. This is a very sensitive model, and it's also very delayed in relaying information to the computer. So we have it isolated under here, so any movement of the air around it doesn't get fed into the computer and cause a false alert on the weather system. In the future, we'll probably end up upgrading this. To simulate wind, we have this computer fan up here, and when this is activated, it blows wind directly down onto the wind sensor there. Those forks up at the top are what detect the wind. This here is a combination temperature and humidity detector. One side is temperature and one side is humidity. And it's shown in these two gauges here, and then it also shows the digital format there. This light comes on, and this red light comes on when there is a temperature over 90 degrees Fahrenheit, and the humidity sensor does not have an alert to go with it. The wind speed sensor has this blue light right here, and then it also trips the siren over here. The siren is tripped off of this relay, and it has 120 volts AC running over here. This is a moisture sensor, and this detects if there is any amount of moisture or water over 2 inches. To simulate that, I have this little thing of water here. I pour it into here, and when this overflows, it flows into this plastic Gladware here. And the sensor detects it and sends an alert. It turns on this blue light right here, and it also turns on this blue light right here, and it is shown in this gauge here. Over here, this is our block diagram, and this is where we coded all of what happens. There's several different loops that tell the Arduino here, which controls everything. It tells it what to do, and all these ports over on this side go to the corresponding relays or lights or sensors, and the information is sent to this screen over here. Next up, we're going to demonstrate the system. We'll begin our demonstration by demonstrating the temperature sensor. The temperature sensor is designed to send an alert to the computer when the temperature reaches over 90 degrees Fahrenheit. That'll trip a light on the computer, which is going to be shown through the other camera, and this red light right here on the breadboard, which you can see on this camera shot. So let's begin the test of our temperature sensor using this hairdryer. Alright, so now we're going to test out our moisture sensor. The way I have this set up is kind of unique. I have a smaller plastic container here, and this holds about 2 inches of water. This would simulate a rain gauge. This is the larger plastic container, and when the small plastic container gets full, it overflows into the larger one. The sensor goes right inside the larger one. And when it detects that there's any amount of moisture, it logs it over there on the computer. And there's a dial and a digital display that shows it right there. So when the water level gets to about 30, or when it's detecting water at about 30 units, for our sake of argument here, it'll trip a light on the computer screen and a light over here on this breadboard. It's this brighter blue one. So let's get started here. So that's about 2 inches of water. It isn't really enough to trip the sensor yet. So luckily I have another thing of water here. So now the water level is rising on the computer, and once it gets to about 30, it'll turn on the blue light. And that's going to happen right about now. And there it went. And then over here on the computer, you can see that there is also a blue light turned on the computer. And as soon as I turn off, or as soon as I pull this out of the water, it doesn't detect any more moisture, so both of the warning lights turn off. Alright, so now we're going to test out our wind sensor. Unfortunately, the part we picked for our wind sensor isn't actually all that fantastic. So it relays false feeds to the computer, and the data is usually incorrect. If I was able to redo this assignment, this would be the one thing that I would fix. I'd get a new wind sensor, and one that didn't relay false feeds, and maybe had like a spinning anemometer on it. But what we have now is what we have, so that's what we're going to be using. So let's test it out. I have to change the wind set point to 40 in order to get this thing to relay the information that we want, and 40 is going to stand for miles per hour. So when the wind reaches about 40 miles per hour, so this thing thinks, it's going to set off the siren. However, right now we seem to be having an issue with it, where it's reading at about 64 miles per hour when there's no wind whatsoever. So right now I'm just going to set it up to about 75, and if I turn on the fan it should reach that level. Okay, well now it's going down, so I'm going to set it back to 40. So now I'm going to turn on the fan, and it's going to run for a couple minutes before it actually gets to the desired wind speed, but when it does get to that speed, you'll see the siren strobe go off and you'll hear the siren. Alright, so it actually went off and it worked. So that demonstrated it pretty well, although the feed was pretty slow, but we did get the results we wanted at the end, so that's a good thing. So I'm going to stop this program here to prevent it from going off.